Hi, everybody. All right, we're going to talk about vertex form, all right? So first, we just need to review what a function is, okay? A function is a relationship between two variables such that each value of the first variable is paired with exactly one value of the second variable. What this means in practice is that every input only has one output. You might remember this as the vertical line test from Algebra 1, where if you had like a graph that, let's say, looked like this would not be a function. Because you can draw a vertical line through it and it crosses more than once. Right? A quadratic function is something that can be written in the form y equals ax squared plus bx plus c, where a, b, and c are real numbers, and a doesn't equal 0. So what's important here is that quadratic means that the degree of the equation is 2. Okay? And the shape of this graph is called a parabola. I've been kind of just throwing that word around and kind of just been hoping you remember something about it. All right? We're going to use what's called vertex form of a quadratic equation or quadratic function. All right? It looks a little bit different than the standard form that we talked about earlier, and we'll talk more about her later. H comma k is the vertex. So y equals a times x minus h squared plus k, and h and k are the vertex. So we're gonna do what I like to call like graphing by transformations or shifts. It's gonna be a useful trick to help us graph faster. And we're gonna use this trick not just for quadratic functions, but we're going to use it for radical functions, polynomial functions, exponential, logarithmic, all the different kinds of functions that we look at this year. So we call this using a modified parent function. Okay. So let's go back to blue. We call this the parent function y equals x squared because it's the most basic form of a quadratic equation. It's just a variable to the second degree. And remember, quadratic means it's to the second degree. So it's the most basic form of it that we can get. And let's just make a quick table of values. If I do x and x squared, right, and I have, let's go out 2 either way and square those numbers. So negative 2 squared is 4. 1, 0, 1, 4. And I go ahead and plot those points. And I get a parabola. Easy. But we're going to do what we call transformations to this parabola. And when we do transformations, it's because we add things in and around the equation. So like we might... we're going to play around with the vertex form of it. Okay? So, I'm going to go... I'm not going to do every single one of these examples with you on the notes. We'll do some of those together in class and give you guys some time to try them out and ask questions. You can try them if you want. Come in with them done, and we can talk about them. It's up to you how you want to handle that. I recommend you trying them at home just so you can get the practice. What I'm going to do is I'm going to do a bunch of them, though, and we'll go from there. So I'm going to do the next one to the right. So y equals 2x squared. Now, I didn't tell you what a does earlier. I said h and k is the vertex. A, I'm just going to draw an arrow over here. It's called the scale factor, okay? And we're going to use a lot this year. So when a is the scale factor, that means that it's going to change the shape of the graph, but not where it's located. All right, it's gonna change how steep it increases if it goes up or down, but it's never going to change the actual location of the graph. So I have x and 2x squared. Negative 2, negative 1, 0, 1, 2. And let's just plug in negative 2 squared is 4 times 2 is 8. So 8, 2, 0, 2, 8. And we just get a much steeper 2, 4, 6, 2, 4, 6, 8. A much steeper parabola. So I want you to just think about what would happen if instead of 2x squared, imagine what would happen then if it was, I don't know, like in this last example, we have 1/2 as our a value. So think about how that would change the graph. Like I said, we're not going to do every example here, but we're going to do a bunch of them. Let's try this guy. Y equals x minus 3 squared. All right, so remember, that means we plugged in 3 for h. And there is no k value. Oops. And there is no k value. So this is, the vertex is at 3, 0. We're going right 3. So I'm just going to go ahead and do that. 1, 2, 3. There's my vertex. I know the vertex is there. Now, I'm going to use my parent function. Because after I take care of that, I moved right 3. I kind of took care of the minus 3 of the situation. So now I just have my parent function left over, right? And that's negative 2, negative 1, 0, 1, 2, 4, 1, 0, 1, 4. And I can just count from my new vertex. I'm just going to pretend like that's the origin. So I go right 1, up 1, left 1, up 1. And then 1, 2, 3, 4. Do the same thing over here. And I have a beautiful parabola that's just shifted to the right 3. So all this did is shift it right 3. The h and k change the location of the parabola. The a changes the shape of the parabola. So if I have x plus 3 squared, that's going to go left 3, and it will be at negative 3, comma 0. So I'm going to go left 3 instead. I'm going to use the same parent function. I'm just going to kind of draw an arrow to kind of signal to you that. And there we go. Again, it's the same parabola, just shifted somewhere else on the coordinate grid. All right, let's combine h and k. This is telling me left 3. Remember, it's always backwards on the inside because the formula is h minus k. It's x minus h. So because it's minus h, it flips the sign. So this is left 3 and up 4. So it's negative 3, comma 4. So I go left 3. 1, 2, 3, up. 1, 2, 3, 4. Up. So, all right, so I'm going to go left 3. 1, 2, 3, up. 1, 2, 3, 4. And again, there's no a value, so I just use the parent function to count from here. And look how beautiful that is. All right. Now, in this next example, it's, again, left 3, up 4. So the vertex is at negative 3, comma 4. Just going to go ahead and notate that. I go left 3 and up 1, 2, 3, 4. But now I have an a value of negative 1. I need to modify my parent function, x, negative x squared. So, negative 2, negative 1, 0, 1, 2. Negative 2 squared is 4, make it negative. Negative 4, negative 1, 0, negative 1, negative 4. So a negative in front you might have guessed this, just shifts the parabola upside down. And there we go. So I'm just going to do this next one, and then we're going to leave the last two as like a kind of like a starter for class. You can try them out and then come in with questions. All right. So here, I'm going to go left 2, up 3. So my vertex is at -2, comma 3. Oop. So my vertex is at -2, comma 3. But my scale factor is 2, so I need to modify my parent function, x and 2x squared. -2, -1, 0, 1, 2, 8, 2, 0, 2, 8. And I don't think this will quite fit, so I'm just gonna, there you go. Okay, everybody. Try the next two, come in with questions, let me know how it goes. Can't wait to see ya.